Let us solve this degree 4 polynomial. Degree 4, that should be very interesting. Well, the first thing I want to do is to get everything on one side. I hope you don't mind. And then plus 16. In that case, this will be equal to 0. And this is a better format because we know how to find roots, more or less, of these kinds of equations. It's much easier to find the root than to say, okay, let me find the solution for this. So that's good. Now, we are given a hint, and that is r is equal to 1, r1 is equal to 2 is a solution. I wrote r1 because I wanted to signify that it is a root. This is not mentioned in the worksheet or the quiz. So, what is our next step? Well, it is very simple. We know that by the fundamental theorem of algebra, this polynomial has the form x minus r1, x minus r2, x minus r3, and then x minus r4. So we know it has 4 roots because it's the degree 4 polynomial, and we want to find these 4 roots. Now, if r is equal to 1, r1 is equal to 2 is a solution, then we can just simply divide this whole thing by x minus r1, right? And we will get a division without remainder, right? There's no remainder because it's just canceling out the factor. So we will get this answer as a result. So it seems like a good idea. Let's actually do it. And dividing by 0 gives you 0. Sorry, no. Do not divide by 0. You should never do that. This is one of the main problems, I can say. Now, let us focus on this polynomial here. We can divide it by x minus r1 using polynomial long division. So the idea is to use polynomial long division because we actually don't know any formulas for n is equal to 4. We know a formula for n is equal to 2, which is the quadratic formula, but for other higher powers, this is not the case. So we still have some way to go. We need to reduce this to a degree 2 polynomial. And one step towards doing that is reducing it to a degree 3 polynomial. So this is going to be a degree 3 polynomial. So I will set up the venue now, and I'll divide by x minus 2, which is the first root. And now x times what gives you x to the 4th? It's x to the 3rd. The next step usually is to take away the product of x cubed and these two things, or whatever gets written here. So you take the product of this thing and x minus 2. So you get x to the 4th. Wow. This is not a surprise because we've chosen it specifically to work in that way. And then you take away 2x cubed. This is just multiplying this by that. Then this cancels out. And you get x cubed plus all the other stuff. And we repeat the same process. So x times what is x cubed? Well, it's x squared. That's positive x squared. So if I multiply x squared by x, I get x cubed. If I multiply x squared by minus 2, I get minus 2x squared. And I'm taking away this whole amount. So this cancels out. And from here I get 6x squared. Repeating this once again, we get plus 6x. And multiplying this by 2, I get minus 12x. We're almost there. Just need to do it one more time, I think. So 12, it's going to be minus 8 x plus 16. And if you divide, if you multiply this by 8, minus 8, sorry, you will get minus 8x plus 16. So we do indeed get a division without any remainders. So I'm happy about that. So r is equal to 0. But this is for beginners, like usually just write r is equal to 0. So this is our degree 3 polynomial that we've been talking about. Maybe I'll actually take a copy of it and then put it there. Oops. And now, what is the next step? So we've done this, okay, good. We're still stuck because we have a degree 3 polynomial. Do we have a formula for it? Well, not really. And for that reason, we need to figure out something else. And the other strategy is guessing, because we don't have anything else to do. So if we are able to guess a root, then in that case, that would be very nice. Already in the choices, I think there is things like -1 and 1 and zeros and stuff like that. But let's say you don't have any choices. If you don't have any choices, you can always try 1 or -1. And well, if you take a look at this, if you take a good look at this, well, 0 is not a root. -1, well, -1 plus 1 plus 6 minus 8. So almost, so we get 7 and 9, so it's -2. But what if I put 1? Then it's 1 plus 1 plus 6. No, it's actually -6 minus 8. So -1 is very far. Do not try -1. I know how to do arithmetic. This is just a small mistake. And for this case, we have 1 plus 1 plus 6 minus 8, which is 0. So 1 is a root. So let's call it R2 is a root. And now repeating the same process gives you the following. Oops. So this will go here. And the answer I actually have prepared over here. And maybe it's a nice exercise for you to check that this will be true. We just need to follow the same methods we've used in the first computation. And from there, what effectively, I remove the word is a root because I think it's a bit redundant. This is already R2. We know that our i's are roots. Now, what we need to do next is I want you to notice that this is also, so if I divide by x minus R2, it's fine. I also do it again here. I'm just confirming that everything is precise and nice. So this is our degree 3 polynomial, and we've already divided it by x minus 1, and that gave us x squared plus 2x minus plus 8. And if you follow this whole sequence of equations, you actually get that this is equal to 0. So again, I'll just write it again. So this is still equal to 0. Because if you divide 0 by something, it's equal to 0. We divided 0 by two things, which are x minus r1 and x minus r2. Now, if this is equal to 0, then it's actually our lucky day, because we know how to work with this. And the way to proceed is by using the quadratic formula. So, quadratic formula tells you that, well, let's first write this in the form that is nice enough. So, xax squared plus bx plus c is the format. Now, clearly from here we get that a is equal to 1, b is equal to 2, and c is equal to 8. Okay, now I can remove this. So these are the coefficients of the terms. 3 terms, so 3 coefficients. And from here I can plug in the formula, which says I need to it's safe to say I don't really have much space. But that's fine. So this is the quadratic formula. If I plug in, I'll actually get that x is equal to... Well, why don't I just use this space? Yeah, so let me utilize the space here. Since we're already done, so why not do this? You'll get that x will be equal to minus 1 plus or minus I square root of 7. This is just simple arithmetic. If you do it, you will get this result. And this is how you proceed. So if you have a degree 4 polynomial, to recap, the goal is really to find the roots and then divide by those. And you can find the roots by guessing. The usual guesses are 0, 1, minus 1, 2, minus 2, for example. But don't go too far. I think more than 5 guesses is too much. And if it's not obvious, then you should not try to guess it, because it's probably not obvious. If it's not made obvious, then it's not obvious. And for these problems, you just need to be careful. You need to do everything slowly, practice very well. And by time, you'll be able to master the skill of solving degree 4 quadratic equations. And you might even brag about it to your friends. Hey, I can solve degree 4 polynomial equations. That's a very rare thing to know. Yeah.